Imagine a world where the human body possesses capabilities far beyond what we typically consider normal. Imagine if you could walk through life, navigate bustling streets and challenging terrains, without ever having to worry about the nagging fear of breaking a bone. Picture this. You're enjoying a leisurely bike ride, feeling the wind in your hair, when suddenly, disaster strikes. You lose control and you find yourself falling off your bike, landing hard on the unforgiving pavement. But instead of the expected agony and potential fractures, you simply dust yourself off, get up with nothing more than a minor scratch on your skin, and continue on your way. Now just think about a world where pain, that constant companion for so many, simply does not exist. A world free from the limitations and suffering it imposes. No more wincing from stubbed toes, no more sleepless nights plagued by throbbing toothaches, and not even the irritating sting of a bee to ruin a perfect summer afternoon. These ideas may sound like the stuff of comic book dreams, fantastical scenarios ripped from the pages of superhero sagas, but believe it or not, for some extraordinary people, these abilities are very real. These rare individuals possess something that scientists are only beginning to understand: superhuman DNA. Their bodies, thanks to unique genetic variations, work in ways that most of us can only imagine, defying the conventional limitations of human physiology. Some have bones so incredibly dense that even powerful X-rays struggle to penetrate them, let alone reveal any signs of fractures or cracks. Others are born with a condition that prevents them from feeling pain at all, living their lives with a kind of invisible shield, seemingly immune to the discomfort and suffering that defines the human experience for so many. These extraordinary traits stem from special changes, subtle yet profound alterations, in their genes, also known as genetic mutations. Those random and often unpredictable tweaks in our DNA that can lead to remarkable variations. Scientists around the globe are understandably fascinated by these real-life superhuman stories. They are eager to unlock the secrets of how these genes work, to understand the underlying mechanisms that grant these individuals their incredible abilities, and what other hidden genetic secrets they might reveal about the untapped potential of the human body. The ultimate question looms large. Could we one day unlock these powers for everyone, harnessing the power of genetic engineering to enhance human capabilities across the board? The answer, it seems, might be hidden deep within the intricate structure of our DNA, waiting to be deciphered. So, let's embark on a journey to explore the real science behind these modern-day superhumans. We'll delve into the specific genes that make some people virtually unbreakable, resistant to fractures and physical trauma, and others completely pain-free, offering a glimpse into a world without suffering. Bones. They're the unsung heroes of our bodies, the hard white structures that form the very framework of who we are. They're so fundamental we often take them for granted. Hidden inside our bodies, they're more than just rigid supports. They're a complex and dynamic system. They hold us up, providing the skeletal scaffolding that allows us to stand tall and maintain our posture. They help us move, acting as levers for our muscles, enabling us to walk, run, jump, and perform countless other actions. And perhaps most importantly, they protect our vital organs, shielding them from harm and ensuring their continued function. Think of the rib cage, a fortress safeguarding the heart and lungs. Most people know what it feels like to break a bone. That sharp, searing pain is a stark reminder of their vulnerability. It hurts, and it takes time to heal, often requiring casts, crutches, and weeks of patience as the body slowly repairs the damage. But for some incredibly fortunate individuals, broken bones are almost impossible. Their skeletal systems possess an extraordinary resilience. Their bones are so dense and strong, far exceeding the average person's, that they can withstand tremendous forces. In fact, they're so remarkable that doctors call them X-ray strong bones, a testament to their exceptional density and resistance to fracture. What's the secret behind these super strong bones? What makes them so incredibly resilient? The answer, as is often the case with extraordinary biological traits, lies in our genes. Genes are like tiny instruction books, meticulously detailed manuals, residing inside every cell of our bodies. They tell the body how to grow, orchestrating the complex processes of development from infancy to adulthood. They dictate how to heal, initiating the intricate cellular repair mechanisms that mend injuries and keep us alive, ensuring our survival. Sometimes a tiny change in one gene, a single alteration in the vast genetic code, can make a big difference. leading to significant variations in our physical characteristics and abilities. This is called a genetic mutation, a spontaneous alteration in the DNA sequence that can have a range of effects. One special gene, called LRP5, plays a crucial role in bone density and strength. It holds the key to unbreakable bones, acting as a master regulator of bone formation and remodeling. When this gene changes in a certain way, when a specific mutation occurs within its code, it makes bones grow extra thick and hard, significantly increasing their density and resistance to fracture. This means that even big falls or hard hits, impacts that would normally result in broken bones, often leave these people unharmed, their bones remaining intact and unscathed thanks to their exceptional strength. Doctors discovered this mutation almost by accident, stumbling upon it during their research into bone disorders. They found families where broken bones were almost unknown, a remarkable anomaly that piqued their scientific curiosity. Their superhuman DNA, the unique genetic blueprint they inherited, made them strong from the inside out, endowing them with bones of extraordinary density and resilience. The LRP5 gene, a critical component of our skeletal system, plays a pivotal role in regulating bone mass and density. It's a gene that scientists have been studying for years, trying to understand its intricate functions. It's like a master switch for bone strength. Think of it as the conductor of an orchestra, ensuring that all the elements work in harmony to build and maintain strong, healthy bones. It dictates how much calcium is deposited and how dense the bone structure becomes. In most people, this gene helps bones grow to their normal size and density, providing the necessary framework and support for our bodies. It ensures that bones are strong enough to withstand daily stresses and prevent fractures. But when a mutation happens, a change in the genetic code, things can go awry. The switch gets stuck in the on position, constantly signaling the body to build more bone. It's like a volume knob turned all the way up, leading to an overproduction of bone tissue. This makes the body build bones that are thicker and denser than usual, far exceeding the normal range. While this might sound like a good thing, it's a result of a genetic anomaly. Scientists have studied families with this mutation, meticulously analyzing their genetic makeup and bone structures. They noticed that their bones looked very different on X-rays, standing out in stark contrast to typical bone images. Instead of the usual see-through look, where X-rays easily penetrate the bone, revealing its internal structure, their bones were almost solid white, indicating an incredibly high density that blocked most of the X-ray radiation. That's why doctors call them X-ray strong bones, a descriptive term that perfectly captures their unique skeletal characteristic. These people rarely get fractures, even if they have serious accidents, showcasing the remarkable resilience of their bones. One famous case comes from a family in Connecticut, whose extraordinary bone density became a subject of intense scientific interest. A doctor noticed that they all had very dense bones, an observation that sparked a deeper investigation into their genetic background. They did not know they were special until later in life, when medical examinations revealed the unusual strength of their skeletal systems. Some family members worked in construction and loved sports, engaging in activities that would typically lead to injuries in individuals with normal bone density. They almost never got hurt, a testament to the protective advantage conferred by their exceptionally dense bones. This discovery led to more research into the LRP5 gene and how it works, aiming to unlock the secrets behind its influence on bone density. Scientists hope that by studying these superhumans, they can help others who suffer from brittle bone diseases and fractures. Maybe one day, we can use this knowledge to treat bone diseases like osteoporosis, offering new hope for those at risk of fractures and debilitating bone weakness. Let's look at a real story of a person with superhuman DNA. Joe, not his real name, grew up in a small town. As a child, he fell out of trees, jumped off sheds, and wrestled with his brothers. He never broke a single bone. His parents thought he was just lucky. It wasn't until Joe was an adult that doctors discovered his secret. He had the LRP5 gene mutation. His bones were almost twice as dense as normal bones. When doctors took X-rays, they saw what looked like solid stone. They called him the Stone Man because of his X-ray strong bones. Joe's family also had the same gene. None of them had ever broken a bone. They joked that they were unbreakable. But this superpower had some downsides too. Their bones were so heavy that some family members had joint pain and trouble moving quickly. Joe's story shows how a tiny change in DNA can make someone almost superhuman. Scientists are still learning from people like him. Now let's meet another group of superhumans. These people have a different kind of power. They cannot feel pain at all. This rare ability comes from a change in the SCN9A gene. This gene controls how nerves send pain signals to the brain. In most people, pain is a warning signal. But when the SCN9A gene is mutated, the body doesn't send these signals. People with this mutation can break a bone, cut themselves, or get burned, and not feel a thing. Doctors first found this mutation in children who kept hurting themselves. They would bite their tongues, touch hot stoves, and walk on broken legs without noticing. At first, their parents were scared, but then doctors realized that these children had a special kind of superhuman DNA. This discovery opened new doors in science. If we can understand how the SCN9A gene works, maybe we can help people who live with too much pain. One of the most famous stories actually comes from a small village in Pakistan. Several children there were known as the Untouchables. They could put knives through their arms or walk on hot coals without even flinching. Crowds would gather to watch them do these strange and honestly dangerous tricks. Doctors studied these children and found they all had the same SCN9A gene mutation. Their nerves worked normally for touch and temperature, but the pain signal was missing. This made life both amazing and, well, risky. Without pain, these children often got hurt badly without even knowing it. One boy named Ashraf became famous for his street performances. He could walk on glass and never bleed. But sadly, he died young because he didn't notice a serious injury. His story is a reminder that pain, while unpleasant, is actually important for survival. Scientists are now trying to use this knowledge to help people with chronic pain. They hope to block pain signals safely, without the dangers faced by Ashraf and his friends. When scientists want to understand superhuman DNA, they use something called a genetic mutation chart. This chart shows where changes happen in our genes. It's kind of like a map of the body's secret codes. For the LRP5 gene, the chart highlights the spots that make bones extra dense. For the SCN9A gene, it shows the place where pain signals get turned off. These charts aren't just for scientists, though. Doctors use them to help families understand their health. If someone has a rare mutation, the chart can show how it might affect their body. It can also help find new treatments and hopefully even prevent some problems before they start. By studying these charts, scientists hope to unlock more superhuman secrets. Maybe there are other hidden powers just waiting to be found. The stories of people with X-ray strong bones and pain-free lives are more than just odd facts. They're actually keys to new medicine. If we can learn how the LRP5 gene builds strong bones, we could help millions with weak bones. If we understand the SCN9A gene, we could create safer painkillers. Scientists are already working on ways to copy these superhuman traits. One idea is to use gene editing to fix broken genes. Another is to make new drugs that act like the off switch for pain. These ideas are still pretty new, but they offer hope for the future. By learning from real superhumans, medicine could change forever. Who knows, we might all have a bit of superhuman DNA one day. The people with unbreakable bones and those who cannot feel pain really show us what the human body can do. Their stories aren't just about luck or strange science. They're about the power hidden in our DNA. Sometimes a single small change can make someone superhuman. But these powers come with challenges too. Having X-ray strong bones can actually make it hard to move. Living without pain can be dangerous. Still, their lives teach us important lessons about balance, safety, and just the marvel of human biology. Science is really just beginning to unlock the secrets of our genes. Who knows what other superhuman traits we might discover? With every new genetic mutation chart, we get closer to a future where everyone can benefit from these amazing abilities. Don't forget to like and subscribe.